Team, it's Mr. Z, and last time we dilated a linear function by multiplying it by x plus 3. Now we're going to basically take the quadratic that was formed by multiplying two lines together, and then we're going to see what happens. So let's go ahead and try to figure out what happens when I multiply m of x, which is this blue portion, and the basic idea is that I'm going to multiply it by x plus 2. So let's go ahead and analyze. Well, let's look at m of x. So it's going to be the input and then the output of the quadratic. So some inputs I'm going to make sure I have are -3, -2, -1. We're going to do 0, 1, 2. Okay, so let's dive in. So -3. When I plugged it last time, basically what I'm going to be looking at is right over here, the outputs. These are the ones I generated last time. So I'm going to steal. This is when x is 0, it's going to be -3. When it's 1, it's 0. When it's 2, it's 5. When it's -1, it's -4. Let's go ahead and review on how to calculate this. So m of x last time was basically taking x plus 3 and multiplying it by x minus 1. So over here is where we're looking. M of x is x plus 3 times x minus 1. So to quickly calculate it without a graph, I would plug in -3 for m of x. So m of -3 is going to be equal to -3 plus 3, -3 minus 1. This would result in 0 times -4, making the output of -3 0. Likewise, if I plugged in -2 into the equation, it would produce the output of +1 times -3, making the output of -2, -3. If I was confident in my sketch of the graph, I could also look at it. This is just a review on algebraically on how to determine them. So the idea is that we have our original m of x. Now we need to multiply it by x of 2. So we have m of x, and now we're going to need to multiply it by x of 2. Well, what is x plus 2? -1, 0, 1, 2, 3, 4. I took the input, the blue input, -3, and added 2 to get -1. Now this is the point where we're just going to be registering the outputs. My first point is going to be -3, comma something. I'm going to figure out all of these points and graph them. So let's go ahead and figure out these new values. 0 times -1. I'm multiplying m of x times x plus 2. And that's going to be a product of 0. -3 times 0 is 0. -4 times 1. -3 times 2. 0 times 3. 5 times 4. Okay, let me graph this guy. -3, comma 0. Notice how in all of these, the original x plus 3, that intercept shows up in all of my graphs. Likewise, -2 will be here. What else? -1, comma -4. 220. It's going to be all the way up here. So the idea of this graph is it's going to look something like There we go. Notice the new equation, p of x is equal to x plus 2 times m of x. P of x is equal to x plus 2 times x plus 3 times x minus 1. Where did I get that from? Well, the above. X plus 3 times x minus 1 is m of x. Notice, team, I have 3 groups, each with an x in it. It is degree 3. Notice 1, 2, 3. The zeros are going to be when it's equal to 0. There's going to be 3 cases, 3 zeros. The first case, so remember my answer is always going to be x comma y. That is the same thing as saying x comma p of x in this case. We have chosen to let p of x be 0. So all of my x-intercepts are going to have a y value of 0. So it's up for me to figure out the x part of each. So what is the first one? What number plus 2 equals 0? The second part, what number plus 3 equals 0? The final part, what number minus 1 is 0? So what do you notice about the dilations of each function and the zeros of each new function? So I noticed that a line dilated by a factor of x results in a quadratic. Likewise, a quadratic dilated by x will be a degree 3 function. All of the roots from earlier dilations remain. This next question is asking, how do the zeros appear to be related to the increasing and decreasing behavior of the function? And explain why do you think this behavior works? So we have a line with an x-intercept, we'll call it here. We'll go with our quadratic, which was our second one, which had 2 x-intercepts. And then our new function, our degree 3, had 3 zeros. Now, remember, all of these points are the x-axis. So if you're above this point, you're a positive number. If you're below this point, you're a negative number. Remember, these are the zeros. So notice, before the x-intercept, it is negative. After, it is positive. Here, it is positive, then negative, then positive. Again, negative, positive. Now you might ask, wait, is it still positive? Yes, it's still positive even though the value is going down until it hits the x-axis, and then it's negative, and then it's positive again.